he must opt least time mode for this stage. Least time mode. Least time mode means he must always swim perpendicular to the flow. But due to the velocity of the river, he drift. What must be the velocity? The velocity when the body returns at the extreme or turning point, the velocity must be zero. So we have to find out at what time velocity becomes zero. We find out that time and substitute in this equation. This is the position of the fourth one. This is the position of the third one. And this is the position of the second one, say. Now we took a photograph of these drops. First drop, second, third, fourth, fifth, sixth one. Next, we shall go to our kinematic chapter. Next chapter. A particle start moving from t is equal to 0 and its coordinate is given as xt is equal to 4tq minus 3t. And we are asked to find out the behavior of that particle at the different distances. That's okay. We are given the function displacement equation. This is position equation xt is equal to 4tq minus 3t. The particle returned to its original position in 0.8 unit later. Particle returned to its original position means displacement must be zero. Now our aim is to find at what time the displacement is zero. Now we are given the displacement equation x or t is equal to 4t cube minus 3t. Now when it returns, xt is equal to 0 and the 0 is equal to 4t cube minus 3t. T into 4t square minus 3 equal to 0. That means 4t square minus 3 is equal to 0 or 4t square is equal to 3. T square is equal to 3 by 4 or t is equal to root of 3 by 4. And that value on calculation is roughly 0.86. 0.75, so root of 0.75 is equal to 0.866. And you know that is our first statement. Particle returned to original position after time. So this one is correct. Way is correct. Now there are 4 options in which they are correct. There are 3 options. We have to verify the other one also. Now the particle in unit time, 1 unit away from origin at its turning point. The particle is 1 unit away from origin at its turning point. Now that can be done, turning point, in 2 ways. You know, the particle 1 unit away from origin at its turning point. At turning point, what must be the velocity? The velocity when the body returns at the extreme or turning point, the velocity must be zero. So we have to find out at what time velocity becomes zero. We find out that time and substitute in this equation, x equation, we get the position where it returns. Got the point? Therefore, we have to see at the turning point velocity is zero. Therefore, we have to get the velocity function. Velocity function is equal to x by dt. Velocity v is equal to dx by dt. Velocity function is equal to differentiating 12 t square minus 3. 12 t square minus 3. And at the turning point, this is equal to 0. 12 t square minus 3 is equal to 0, or t square is equal to 3 by 12 is equal to 1 by 4, or t is equal to 1 by 2. 0.5 second. The body retained at 0.5 second. Is that option is there anywhere? That is not there. Now we have to say at that time, what is the value of xt? Now substituting at this time, x the turning point, x turning point, x at a time 0.5 is equal to 4 into 0.5 whole squared minus 3 into 0.5. Sorry. TQ. Minus 3 into 0.5. That is the position, the value of x at the time 0.5 second. That on calculation give you the value 1. This on calculation, the value is equal to 1. That means the particle is 1 unit away from origin at its turning point. So B is correct. B is correct. If B is correct, the particle is 0.5 unit away from origin at its turning point is wrong. This is wrong. Acceleration of the particle is non-negative. Next one. Particle never turn back as acceleration is non-negative. Particle never turn back as the acceleration is non-negative. We found that there is a position from where the body returned. And therefore, definitely this statement is wrong. But now we have to see whether acceleration of the particle is non-negative. To get that, we got the velocity equation. Velocity equation is this one. Then what is the acceleration equation? Acceleration is equal to dv by dt. That on calculation is equal to 2040. 2040. Equal to 2040. And t never be negative, and therefore acceleration never be negative. Never be negative. The acceleration of the particle is non-negative. This statement is correct. Therefore, we can say that A, B, C are correct. So option is equal to 4. Okay. Go to our next question. Water drops fall from tap on a floor 5 meters below at a regular interval of time. The first drop strikes the floor when the sixth drop begin to fall. The height at which the fourth drop will be from the ground at the instant when the first drop strikes the ground is. Now this is the position from the drops, and this is the ground, and the height is equal to 5 meters. Now we are going to take a flash photograph of the situation. That is, the first drop is here, 1 minute. Sixth drop is here, and this is 5 meters. Sixth drop just going to release, the first drop hit here. Then this is the position of the fifth one. This is the position of the fourth one. This is the position of the fourth one. This is the position of the third one. And this is the position of the second one. Say. Now we took a photograph of these drops. First drop, second, third, fourth, fifth, sixth one. And the problem says the sixth just going to release. First one hit the ground, and separation between them is a meter. Now apply at a regular interval they are dipped, and therefore you can apply the Galilei law odd numbers. In equal interval of time, the displacement are in the ratio 1:2. 3:5, etc. And therefore, if this is x, this is 3x, this is 5x, this is 7x, this is 9x. 1:3:5:7:9. Galileo law of odd numbers. Add up x plus 3x plus 5x plus 7x plus 9x. Give you the separation between first and sixth, that is equal to 5 meters. Adding 16, 21, 24, 25. 25x is equal to 5 meters. So x is equal to 5 by 25 to 1 by 5 meters. That is the value of x. Now what is the question? The height at which the fourth drop will be from the ground at the instant when first drop. This height. This is the fourth one. And what is this height? That height from here is equal to 9x plus 7x plus 5x. So our answer is 9x plus 7x plus 5x is equal to 21x. Equal to 21 into 5 by 1 by 5. 4.2 meter. So the answer is 4.2 meter. Rather than applying half GT square, etc., we can directly apply the Galileo of odd number and get the answer quickly. Okay. Velocity v, distance x, graph is shown in figure. The graph represents the acceleration versus distance x, variation of the system. Now we are given velocity x graph. You can see there is a straight line with the positive y-intercept, negative slope. And hence, you can write down the general format or equation of velocity connected with x. But the equation generally represents y is equal to, v is equal to, minus, because slope is negative, slope minus slope into x, plus y-intercept. Y-intercept, say this is equal to v0. This point is v0, we can say v0. This is the equation of this graph. Minus, and the value of k, if you want, you can get the value of k also. K is equal to v0, this is x0. Then k is equal to y by x, v0 by x0. If you want, you can write like this. But we are keeping that k itself, where k is the slope, negative slope. This is v. Then, if you differentiate, what is dv by dx? dv by dx is equal to minus, that is slope of this equation. That is dv by dx. Now, why we are doing all this? Because we are asked to find acceleration versus distance. Acceleration versus distance, A and acceleration. You know A is equal to, acceleration A is equal to, equation is equal to dv by dt or v into dv by dx. This is the formula for acceleration. V into, in terms of x, v into dv by dx. Therefore, A is equal to v into dv by dx is already there with us. Minus k. V already there with us. Substitute here. So minus kx plus v0 into, that is our v. dv by dx is equal to minus k. Equal to k square x minus k v0. That is acceleration. This is the acceleration equation. Acceleration equation, you can see that again, the constant depend on x, but there is a linear graph. Slope is positive, k square. Slope is k square. And y-intercept is negative. Y-intercept is negative. That means straight line, positive slope, negative y-intercept. Go through this and get the option for that. Now, this is the graph in which you can say that positive slope, negative y-intercept, and therefore this is our option. So option is equal to 4. It's okay. A boy throw a ball into air at 45 degree from the horizontal to land it on the roof of a building of height h. If the ball attain maximum height 2 seconds, land on the building in 3 seconds after the launch, the value of h is, where h is the height of. Now we can, so this is the path. The body thrown at an angle 45, went up the maximum height and reached. Here is our building. This is the building. Reached here like this. This is the building. And what is ours? The value of h. What is that? The building of height h. So we are asked to find what is this h, height of the building. And the ball is thrown at an angle 45, land on the roof of building of height h. If the ball attained maximum height 2 seconds, to reach here it took 2 seconds. Problem is that body projected at an angle 45 reach the maximum height in 2 seconds. Then from there it reaches here. It reached on the building. That's okay. Then what is this h? Suppose we can calculate this height. That is the maximum height of the projectile. And suppose we can calculate this height. Then h is equal to this minus this. That's okay. What is this? We are given the what is the time taken by the body to reach the maximum height? It is given 2 seconds. Then it is symmetric, and therefore what is the total time of flight of this body? 2 seconds to reach the highest point, 2 seconds to return back, 4 seconds. The time of flight of this body, time of flight is equal to 4 seconds. If time of flight is given, you can calculate the vertical height reached by the projectile. Time of flight is given. The vertical height, that is 1. HV. Suppose we call it as HV. Then HV is equal to vertical height. It's equal to T square G by 8. It's equal to 4 squared into 10 by 8. 16 into 10 by 8. 20 meter. Now this is 20 meter. This is 20 meter. Okay, yes. Now we have to find this one. This is small h, if I say. Now here in the vertical direction is a dropped body. Because I is 1, vertical velocity is 0. Now it is returning. There was a dropped body along the vertical direction. And it traveled, how much time it traveled from here to here? To reach here it is 3 seconds. And to reach here is 3 seconds. And therefore for this journey, time is equal to 1 second. Which is a dropped body in 1 second. What the point I think? To reach here 2 seconds. To reach here 3 seconds. And therefore to travel this vertical height as a dropped body, it took 1 second. For a dropped body in 1 second, what is the distance traveled? So h, small h is given by a dropped body in 1 second of gt square. Of gt square is equal to half into 10 into what? 5 meter. So this is 5 meter. Now the question is, what is the height of the building? We already wrote down the height of the building h is equal to hv minus h. Is equal to 20 minus 5, 15 meter. So that is our answer. 15 meter. Okay, we can go to our next question. A fat rope jump from an aeroplane and open a parachute after 2 seconds of free fall and start decelerating with a 3 meter per second square at a 10-meter height from the ground while descending with the help of parachute. The speed of the paratrooper is 5 meters per second. The initial height of the aeroplane. Now see, we did earlier. See what is the situation. Suppose it is a plane from which the paratrooper drops. He is a freely falling body, free fall. For how much time? Paratrooper jump from the aeroplane and jump and open the parachute after 2 seconds. 2 second free fall. So that is the free fall. Free fall for 2 seconds. What is the distance traveled? Half into 10 into 2 square. 20 meters. Now if went down 20 meter free fall, half GT square, dropped and free fall. And what is the velocity? And here on reaching, he opened the chute like this. And what is the velocity of that man the moment when you switch on the parachute? Equal to GT, free fall, V is equal to U plus AT, GT. Here the velocity at this position is equal to GT is equal to 10 into 2, 20 meters per second. From there, what he is doing, he is going with a deceleration of A is equal to minus 3 meters per second square. And at a 10 meter height from the ground, suppose this is the ground, and from this is 10 meters, and on reaching here, from here to here, on reaching here, when the person reaches here, it is said that when he is 10 meters from the ground, what is said in the problem? 10 meter height from the while descending with the help of a parachute, speed of the paratroop is 5. So here is V is equal to 5 meters per second. Initial height of the airplane, that is us. Now, for this journey, you know, you are given U, you are given A, we are given V, and this distance we say yes. This distance if you say yes, then S is equal to what? Now V square is equal to U square. V square is equal to U square plus 2AS. Write down here V square is equal to 5 square is equal to U square 20 minus 2 into 3 into S. From this S is equal to 20 square minus 5 square by 2 into 3. That on calculation is 62.5 meter. This on calculation 62.5 meter. Mathematical value you can do. That is equal to 25 into 15 by 2 into 3. That is the value. That is equal to 62.5. Now the question is, what is the total? Now this distance is 20 meter, this is 10 meter, and this you already calculated 62.5. Therefore, total distance is equal to 20 plus 62.5 plus 10. It's equal to 92.5 meter distance. Next one. An object is projected with a kinetic energy K from a point A at an angle 60 degree with the horizontal. The ratio of the difference in kinetic energy, the point B and C. Difference in kinetic energy between the points B and C to that at the point A. We have to find the difference in kinetic energy between these 2 points and they divide with the kinetic energy at a initial kinetic energy. That's okay. You know the difference in kinetic energy between these 2 points. Difference in kinetic energy, the body projected at an angle 60 degree, and therefore here the kinetic energy is K at the point at A. Kinetic energy is equal to K. At B, kinetic energy is equal to here is equal to mu square is equal to mu cos theta whole square. Therefore, kinetic energy is equal to K cos squared 60. That is the kinetic energy at this point B. Is equal to K by cos 60, 1 by 2 square, 1 by 4. And reaching here, again it is equal to K. At C, it's equal to K. So what is the difference in kinetic energy? Difference between kinetic energy between B and C, C and B, equal to K minus K by 4. That the difference in kinetic energy at these 2 points is equal to 3 by 4K. Now what is asked? This difference by initial kinetic energy. For our answer is 3 by 4K by K equal to 3 by 4. 3 is to 4. 3 is 4. So the answer is here. Okay. We shall go to our next question. A projectile is thrown upward at an angle 60 degree with the horizontal. The speed of the projectile is 20 meters per second when its direction of motion is 45 degree with the horizontal. The initial speed of the projectile is, that is what is asked. Now we can draw, from here we are projecting the body at an angle 60 degree. Now this is 60 degree. And initial velocity is given to 20 meters per second. Now the path will be like this and reach the maximum here. But there is a location where given that suppose when it reaches here, make an angle 45 degree with the horizontal. Velocity is going to be dash. This is 45 degree. At that location, here it was 60 with the horizontal, here is equal to 45. But what the speed become v dash with the horizontal. Now question is, sorry, I'm so sorry. Initial speed is, see, this is, I am wrong. It is, this is not. Now this is v. And here v dash is given to you. The problem, I'm sorry. The speed of the projectile is 20 meters per second when its direction of motion make 45 degree. So here it is 20 meters per second. Then what is B? They are asking. You know that for a projectile, anywhere during its flight, horizontal projection from the ground, throughout the flight, anywhere, horizontal component of velocity is the same. Therefore, we can write P cos 60 is equal to P dash cos 45. And P is equal to P dash is 20. Cos 45 1 by root 2 by cos 60. Cos 60 is equal to 1 by 2. Is equal to 20 root 2 meter per second. So the answer is okay. Next question. A river About the 200 meters is flowing from west to east with the speed 18 kilometers per hour. Kilometer per hour means divided by 8, 5 meters per second. 5 meters per second. Body move with the speed of 36. 36 means 10 meters per second. In still water. It made it to travel one round trip bank to bank of the river. Minimum time taken by the boat for this journey and also the displacement along the river bank. Minimum, therefore, he must opt least time mode for this journey. Least time mode. Least time mode means he must always swim perpendicular to the flow. But due to the velocity of the river, he drift. And hence, the path, actual path seen by you when he swim from here A, and this is the direction of flow of the river. He swim perpendicular to the flow, but the path will be like this. And we just see. This is the path taken by him. He is always swimming perpendicular to the flow, but due to the river velocity, he drift and reaches here. Now the question, two questions are there. What is the time? In least time mode, if d is the distance, d is the width of the river, and v is the velocity of the man, and the time to cross the river is going to be d by v. And to return back again d by v. And therefore total swimming time in this, least time taken by him to complete this task is equal to 2 into d by v. Is equal to 2 into least time is equal to 2t, equal to 2 into d, width of the river is given to you. A river 200 meters by velocity of the swimmer. What is speed? Boat with a speed of 10 meters per second, right? Cancel out 40 seconds. Time taken is 40. Now there are three options, 40. Next, what is the drift, total drift? Drift is given by, he is drifted in the direction of the river by river velocity for how much time? 40 seconds. And the drift, suppose this is A, B, C. So AC is equal to velocity of the river 5 meters per second. The time is equal to 40 seconds, 200 meters. And therefore, the answer is this one. Just. Now, this finishes our first two chapters, units and dimension and kinematics. We meet again like this similar video from the coming chapters. Thank you.